Welcome to Science Corner Tutorials. We'll be looking at science concepts in depth. Get ready. Let's get started. This is the second video on proof of identities. So we are just continuing with, making sure that we understand the standard identities that we have so that, we do find it very easy for us to apply when we start to give examples and solving them. So remember previously on the double angle formula identities, we agreed that cos of A plus B um, is equal to cos of A cos B minus sine of A sine of B. Then also that sine of A plus B equal to sine of A cos B plus sine of B cos of A. So this one we have agreed before. So for us to further derive other standard identities that we are supposed to be able to use, we can now replace B right here with A for us to be have identical terms inside the bracket. So remember that the other time we had cos of A plus B, then we also had cos of A minus B. So if we've got a similar term on the second part here, we're going to get 0. So we're only going to be able to do it on identities where we've got different where we've got a positive sign, right? Because if we've got a negative sign, we're going to get a 0. So cos A plus cos of A, applying the same standard principle that we have here, is called cos of A minus, because here you've got a plus, sine of A, sine of A. So this is the right hand side is similar to cos of 2A, which is equal to cos A multiplied by cos of A is cos squared of A minus sine squared of A. So if we now decide to remove, right, sine squared of A, so that we can be left with cos only, we are going to apply one of the standard identities that we found earlier on, sorry, is which was cos squared theta plus sine squared theta equal to 1. So we can make sine squared theta the subject of the formula. So that is what we've done here. So if you make sine squared theta subject of the formula, you're going to get 1 minus cos squared theta being equal to sine squared theta. Meaning to say where we've got sine squared theta, we can substitute with 1 minus cos squared theta. That's where 1 minus cos squared theta here come from, right? So it's cos squared A minus 1 plus negative here multiplied by negative cos squared of A, right? Then ultimately we're going to get 2 cos squared of A, right, minus 1. So it means that another identity that we also have to keep in our mind is cos 2A is equivalent to 2 cos squared of A minus 1. That's what we have here, right? So we can also choose, dealing with this one, right? We can also choose to make cos squared A the subject of the formula. So how do we go about doing that? Remember, we've got cos 2A is equal to 2 cos squared A minus 1. So it means that if we're going to make cos squared A subject of the formula, which is here, we're going to leave it on its own side, right? So it's cos 2A, negative here, it will become positive on the right hand side, is equal to 2 cos squared A. Hence 2 cos squared A is equal to, we divide both sides, right, by 2 here, right? 2 cos squared A is equal to 1 over 2 cos 2A plus 1. This is another standard identity that we have here. So I want you to note the relationship that we have. So it's cos squared A is equal to 1 over 2 cos 2A plus 1, right? So, and when we change, right, we put a factor to A here. Remember, here is 1. The factor of A here is 1. And the factor of A here is 2 on the um, left hand side. So it means that if we're going to put a 2 here, on the left hand side, we're going to multiply 2 by 2. So you're going to put 2 here, here we're going to have 4. If you put 3 here, right, it means that on the right hand side, right, we're going to multiply 3, multiply by 3, so it will be, this is half of this, so it will be 6. Clear. So it means that cos squared 2a, which is what we have here, we're just going to substitute using the above identity that we have. We're going to substitute, we're going to get the half, if we're going to multiply 2 here, multiply it by 2, we're going to get 4a plus 1. So this is another identity. So it means that if you are given cos squared 2x plus 1, it will be cos 1 over 2 cos of 4x plus 2 plus 1. So I want you to note this very, very important relationship, right, that we have. So it's basically you being able to derive other standard identities from this basic identity that we have. Then we move now to dealing with sign. So when we are dealing with sign, it's sine A plus sine A. So if we expand it, we're going to get sine of A cos of A, right? Plus sine of A cos of A, which is going to give us ultimately 2 sine A cos A. So it means sine of 2A is equal to 2 sine A cos of A, right? So, but remember previously, we decided to substitute sine squared A. So this time around, we can also choose to substitute cos squared A. So cos squared A is similar to 1 minus sine squared of A. So it means that cos 2A is equal to 1 minus sine squared A minus sine squared A. Ultimately, we're going to get cos 2A is equal to 1 minus 2 sine squared of A. So this is also another standard identity that we have. Now, if cos 2A is equal to 1 minus 2 sine squared A, we can choose to make sine squared A the subject of the formula. It's quite straightforward, right? So ultimately, we are going to get sine squared A is equal to 1 over 2, 1 minus cos of 2A, right? So the relationship that we have is also similar. Here we've got 1 as the cofactor of A. Here we've got 2. So it's 1, then we've got 2. So it means if we're going to put 2 here, here we're going to put 4, right? So it's also important for us to bear in mind this very, very important relationship, right? Then from there, another identity that we also have is tan. So it's tan A plus B. The standard identity of that is tan of A plus tan of B, right? You just expand the upper parts, the numerator, over 1 minus tan of A, tan of B, right? So this is also another standard identity that we have. Then when we have got tan of A minus B, it's tan of A minus tan of B, 1 plus tan of A, tan of B. So this is also another standard identity that we have. So take note that when we've got a negative sign here, on the numerator, we're going to maintain the negative sign. But on the denominator, when we've got a negative sign on the left-hand side, we're going to have a positive sign here, which is also the same as what we have done here. We've got a positive sign here, so we maintain the positive sign. But on the numerator, on the denominator, we're going to put a negative sign. So those are the basics that we've got to keep in mind, right? I think that is pretty much it on standard identity. So make sure that you are able to recall. I know there are quite a lot, but put in effort to make sure that you can recall them. They are easy, right? If you can just drive them, they are very easy. And now on the next video, we're going to be looking at examples of how we will be using these standard identities to prove identities. Thank you once again, ladies and gentlemen.